Hello, everybody. Welcome to my channel Island Daily. My name is Dr. Eamon and I'm an optometrist. And today we're going to learn about corneal topography. So let's get started. So there are two terms which are used side by side: corneal topography and tomography. Topography means that you have only the information of the interior surface, only the interior surface, right? And in tomography, you basically have a 2D image of the interior plus the posterior surface. It's actually a B scan formed by multiple A scans, which gives a 2D image. Now, the corneal topography has the basis of keratometry. Keratometer was the first instrument we used to give us information about the corneal curvature and the corneal size. So, what is the basis of keratometry? Its basis is the first Purkinje image. Now, when I was young, I used to think a lot about what is this Purkinje image and how is this going to make us understand how it is going to help us find out the curvature of the cornea. So, because we know that eye has multiple refractive structures, the first structure, the first surface, which is the interior surface of the cornea, act as a convex mirror. It do reflects light, but some of the light is also reflected back, which makes the first Purkinje image. Now, because the convex mirror makes virtual and erect image, it is going to present as virtual and erect. The second surface, also the first Purkinje image, is the brightest one because there is a lot of refractive index between the air and the first refracting surface, whose refractive index is 1.37 while that of air is 1. So that's a huge difference. Now, the second Purkinje image, which is found at the second posterior surface of the cornea, also act as a convex mirror, but because there is no huge difference between the refractive indices, this image is not going to be as bright as the first one, right? Now, the third is going to form at the interior surface of the lens, which also act as a convex mirror. So the first three Purkinje images are going to be virtual and erect. First, three, one. Now, because the fourth surface, which is the posterior surface of the lens, with respect to the direction of light, act as a concave mirror. The fourth Purkinje image is going to be real and inverted, right? Now, our concern is with this first Purkinje image because this first Purkinje image is going to give us the insight about the corneal curvature. Now, in order to calculate the corneal curvature from the first Purkinje image, there is a simple formula of magnification which is m is equals to I over O is equals to V over U, where I is the image size, O is the object size, V is the image distance, and U is the object distance. Now, if we take that the object is at infinity, right? Now the formula will become m is equals to I over O is equals to F over U. Now, some of you may ask that if I'm talking about the object, then why am I placing the focal length at the position of the image? Because in keratometry, we are taking image as the object, right? This first Purkinje image is going to act as an object, right? Now, we know that F focal length is the half of the radius, sorry, right? Now, we are going to make it even more simpler to you. Now, because we want the radius, it is going to be like r is equals to 2ui over o, where u is constant for every device, I is the image size, and o is the object size, right? So this how we are going to calculate the radius of the cornea. And from this formula, after finding out the radius, we can also find out the power of the cornea, which is d is equals to n2 minus n1 over r. So n2 is the refractive index of the second medium, sorry, and n1 is the refractive index of the first medium. So which, if we are talking about the first Purkinje image, this is going to be n minus 1, because the first refractive index is the air, of course, and the second refractive index is going to be the refractive index of the cornea and radius, right, in millimeters. So this was all some mathematical calculations of how are we going to calculate radius and power through the first Purkinje image. So this was the basis. Now, the keratometer only measures the central 3 millimeter of the cornea, right? And the modern topographers or video keratoscopes measure all the cornea but excluding central 3 millimeter of the zone. So this is the advantage of the keratometer, that it does not misses the central optical zone. However, the topographers, the video keratoscopes, these excludes the central 3 millimeter zone. And I am going to ask you a question regarding this in the near future, so you have to keep this concept in mind. Now, after that, more advancements took place, and the scientists decided to make a new technology, which is called the shiftless technology. Now, what happens in this? It creates a 3D model of the cornea, right? Now, what happens in this is that there are three planes. One is the picture plane, the other one is the object plane, and the third one is the film plane. Now, to make a 3D image, these three planes, one of them has to be perpendicular. It should intersect the other plane. Sorry. Now, to make this, a graph should be made like this if the picture plane, the object plane, and the film plane needs to intersect each other at a single point. Now let's make it even more simpler. In Schemflick technology, a 360-degree rotating camera is used in order to take picture of the cornea from every angle and then make a 3D image. Now, based on the shim technology, four of the devices of different brands are introduced in the market. Those are TMS5, which is Tomy Nagaya, and as the name suggests, it's from Japan, right? The other one is the Pentacam, which sounds even more familiar. It's from the Oculus, Wetzlar, and it's from Germany. The other one is the Sirius, which is less used than the Pentacam, sorry, from CSO and Florence, Italy. The other one is the Galili scan, and the company is Zymer, and of course, it's from Switzerland. Now we are going to compare all these scans with each other. Since TMS Nagaya is not much used, so we are not going to talk about it much. So we are going to compare Pentacam, Galili scan, and the series. Now, what happens in the Pentacam? In the Pentacam, we have one fixed camera and one rotating camera. Also, there is no Placido disc in the Pentacam. Now, what does these cameras do? A fixating camera used to locate the position of the eye to make sure that eye doesn't move. And a rotating camera moves 360 degrees and take pictures from the interior and posterior surface of the cornea. Now, there's one thing. How does it take pictures? This right here is the pupil. This is the iris. Now, the camera is going to place here. Let's say if it's in this position, it's going to take image of the cornea plus it will go inside and take image of the angle as well. Since we also do interior segment OCD and interior segment, we also use to observe interior segment with a corneal topography. So it also measures the angle and also measures the thickness and the posterior and anterior segment of the cornea. Now it moves 360 degree and take these pictures like this, right? And a fixating camera actually observes the position of the eye and see if the eye is moving or not. Now in the Galili scan, we have two rotating cameras and no fixating camera, right? Now these two rotating cameras, also there is a Placido disc. Now these two rotating cameras will move in opposite directions, and their movement and the pictures, and there will be an average of these pictures. So if there is a difference between these two pictures, an average will be taken, and so it will be observed that if the eye has moved or not, because there is no fixating camera. Now, Galili, due to this reason, is slightly less reliable than Pentacam because Pentacam has a fixating camera and it actually observes if the eye has moved or not. In the series, we have a placido disc and a rotating camera. So the reason is, in the researches, almost always pentacam and Galili scan are compared, and their values are almost always similar, though the corneal astigmatism has been given very accurately by pentacam, though the series scan gives very accurate same K values. So this was whole for today. We have only an introduction of what is corneal topography and different models and how they do work and what is Schimflick technique and what is the principle of corneal topography. So I hope I have made everything clear. In the next video, we are going to discuss about different readings and different maps and what else does this different scans do hold. So let's share this video with your fellows and do like, share, and subscribe. Thank you very much.